Hi guys, so welcome back sa ating YouTube channel. So ito na yung lesson, I think lesson 4 sa ating application of differential calculus. So sa ating calculus 3, so we have the second derivative test. So on previous video, pinag-aralan natin sa FDT or the first derivative test. So naalala nyo, medyo mahaba yung procedure, then may table or may summary of table tayo na sagot sa dulo. Okay, so dito isa na example lang yung binigay ko kasi nga similar din naman siya. So dito actually parang mas madali siya. So ito yung another way para ma-determine natin kung ano yung mga ekstrema ng ating isang function. Okay, so procedure number 1, differentiate the given function y is equal to f of x, so similar do sa FDT. Equate the first derivative of the function y is equal to f of x to 0 and determine the roots for x. Substitute the value of x in the given function to determine the critical points. Okay, after nan, determine the second derivative of the given function y is equal to f of x. Okay, so again, nakuha ko yung critical points, tapos nahanap ko yung aking second derivative. So, kunin ko yung second derivative. Okay, then test the second derivative. Okay, so again, hindi mo equate yung second derivative sa 0. Although, i-equate mo siya pag kukunin sa inflection point. Okay, so test the second derivative. So, second derivative, kaya nga second derivative test. Test the second derivative by substituting the abscissa of each point. So, meaning, yung dalawang critical point, i-substitute mo dun sa second derivative, yung abscissa nun. So, hindi ka pipili ng mas mababa o mas mataas. Basta sakto i-substitute mo. Okay, ngayon, i-check natin, if the sign of y double prime is negative, the critical point sa maximum local extrema. If a sign of y double prime is positive, the critical point sa minimum local extrema. If y double prime is equal to 0, ay y double prime is equal to infinity, apply the first derivative test. Okay, so kasi ito ang gagawin ko. Ang gagawin ko dito, i-apply ko yung first derivative. So, ipapakita ko na magpipail si first derivative dito para malaman mo naman sa ganun. Pero ito talaga totally. So, pag sinabi ko use second derivative test, syempre ang gagawin mo na, punta ka agad sa second derivative. So, hindi ka na mag-test ng less than, tas greater than, tas tuloy-tuloy ka lang ganito. So, ngayon, kung dumating yung point, isa sa mga critical points natin, nung tinest mo siya, o isa sa mga abscissa ng critical points natin, tinest mo sa second derivative, tas nagkaroon ng 0 or y ng infinity, therefore, first derivative test. Pero, in this example, again, ulitin ko, mag-i-start ako using the first derivative test. Ipapakita ko na siya ay magpe-fail para i-apply natin si first derivative. Okay, so proceed tayo dito. So, meaning, ganito yan. Dalawa yung choices mo. So, it's either gamitin mo si first derivative or sa second derivative test. So, kunwari wala akong nilagay, so find the local extrema. So, find all critical points, inflection point or points, concavity and local extrema of the function. So, kunyari wala akong sinabi kung FDT or SDT yung gagamitin natin. So, meaning may laya kang gamitin sa second derivative test. So, ito yung kagandahan. Pag nangyari to, ibig sabihin first derivative test talaga yung gagamitin mo. So, meaning hulaan din to totally. So, ayun yung mga gagawin ko para medyo hindi naman maging challenging yung topic natin yun. Okay, so for number 1 or for our example, nag-iisang example. So, determine all the critical points, inflection point or points, concavity, and local extrema of the function y is equal to 2x cubed minus 9x squared plus 12x plus 4. Okay, so again, by FDT muna yung gagamitin ko. So, by FDT, so para makita nyo nag-fail, kunin natin yung y prime. Y prime is equal to 6x squared minus 18x plus 12. Okay, then let natin to y prime is equal to 0. So, this is just 0 is equal to 6x squared minus 18x plus 12. Then, divide natin lahat by 6, I think, para ma-reduce yung equation. So, divide by 6, this is 0 is equal to x squared minus 3x plus 2. Then, find the value of x. Okay, so, pag nahanap natin yung value ng x, anong gagawin? Obviously, yung value dito is 0 is equal to x minus 2, then x minus 1 by factoring. Okay, then pag pinaghiwalay, this is just equal sa x minus 2 is equal to 0. Okay, therefore, this is x is equal to 2 or x sub 1 is equal to 2. Okay, then next is x minus 1 is equal to 0. Therefore, x sub 2 is equal to 1. So, kunin natin y sub 1. So, y sub 1, substitute lang natin x sub 1 dun sa original equation. So, this is just 2 times 2 cube minus 9 times 2 square plus 12 times 2. Okay, then plus 4. Okay, then y sub 1 is just equal sa, I guess this is equal sa ating That is 8, 16 minus 36, so negative 20. So 20 plus 24, that's 4. That's 4. So I think that is tama ba? 4 plus 4. Sige nga, so 16 minus 36, negative 20. Negative 20 plus 24, that is 24. Negative 20 plus 24, that's 4. 4 plus 4 is 8. Okay, so I guess 8 siya. Okay, so tama, 8 siya. So y sub 1 is 8. So meaning yung p sub 1 natin is equal sa 2, 8. So nag-compute pa ako kung ano-ano. Sorry. So then this is y sub 2 is equal to 2 times 1 raised to 3 minus 9 times 1 squared plus 12 times 1 plus 4. So y sub 2 is just equal sa 2 minus 9 is negative 7 plus 12, that is negative 7 plus 12, that is 5 plus 4, that is 9. Okay, so that is 9. So yung p sub 2 natin is just equal sa 1, 9. Okay, so before tayo mag-FDT or mag-second derivative test, kunin natin yung inflection point. So for inflection point, dito ko nalagay. So for inflection point, since isa lang naman yung inflection kasi dalawa lang yung critical, so ang gagawin natin, equate natin yung double, yung y prime sa kunin natin second derivative, so that's y double prime. Okay, so y double prime is equal to 12x minus 18. Equate to sa 0, this is 0 is equal to 12x minus 18, or simply 18 is equal to 12x, or x is just equal sa 3 over 2. Okay, so this is 3 over 2. Okay, then so ito yung x sub ip natin. So kunin natin yung y sub ip. So balik tayo sa first origin, sa first equation or sa ating first function. So equation again, function siya. So that is 2x cubed. So that is 2 times 3 over 2 cube minus 9 times 3 over 2 square plus 12 times 3 over 2 plus 4. Okay, then y sub ip, using calculator mo na lang, recta natin. So that is simply 17 over 2. So meaning yung inflection point o yung p sub ip natin is just equal sa 3 over 2, 17 over 2. Ang kagandahan, may second derivative pa tayo. Okay, so kasi second derivative ta siyang gagawin. Okay, ngayon, since FDT yung gagamitin natin, kunin natin yung isang abscissa. So for P1, so dito na lang. So for P1, for P sub 1 na equal sa 2, 8. Okay, so for P sub 1 is equal to 2, 8. Kunin natin, so at x sub 1 is equal to 2, we have x less than x sub 1. Ano yung pipiliin? Choose natin x is equal to 1. Okay, then substitute natin sa first derivative kasi nga FDT yung ginagamit natin, although sa SDT tayo. So choose x is equal to 1. So that is y sub 1 is equal to 6 times 1 squared minus 18 times 1 plus 12. Okay, kung napapansin mo, 6 minus 18 plus 12, so this is negative 12 plus 12. So y prime is 0. Okay, so note na siya ay nag-0. Okay, since may nag-exist na y prime is equal to 0, obviously, first derivative test is not applicable. So lagay ko lang, the function, so again, the function can't be tested. So can't be tested by FDT or by first derivative test. Okay, since y prime is equal to 0. So at a value less than pa lang, no? Lesser than x sub 1. Okay, so since hindi applicable si first derivative test, kasi sabi ni first derivative test, no, basta may isang mag-0, kahit hindi mo pa chine-check yung isa, automatic second derivative test tayo. Okay, so by second derivative test, so by SDT. So ano ibig sabihin, sir? Etong pagkuha na to, similar sila ni SDT. So ito na siguro yung pwede natin maging parang general solution sa atin. Kunin mo yung inflection, okay, kunin mo yung mga critical points at the same time inflection point. Tapos, dito ka na mamili. FDT ka muna. Kung may mag-fail na, automatic SDT ka. So, ano sabi ng SDT? Determine the second derivative by substituting the abscissa. So, again, determine the second derivative of the given function. So, since ito yung given function, tapos nag-inflection point tayo, may second derivative na tayo. Okay, note na yung second derivative natin is equal to 12x minus 18. Okay, so yung abscissa nung P1 saka nung P2, diyan natin isa-substitute. So, at P1, okay, so at P1, that is 2, 8. Excuse me. So, gagamitin ko yung 2, substitute ko doon. So, check ko yung value ng y double prime. So, y double prime is just equals to 12 times 2 minus 18. Okay? So, obviously, y double prime is just equals to 24 minus 18. That is positive 6. Okay? Next is at P2 or P sub 2. P sub 2 is 1, 9, okay, so that's 1, 9, so meaning yung abscissa natin is equal sa 1, so y double prime is equal sa 12 times 1 minus 18, then y double prime is equal sa negative 6, I guess. Tama, so that is negative 6, so napansin mo, positive tas negative, so dalawa yung nakita kong value, so at least walang 0 or infinity na lumabas. So therefore by SDT pwede natin pangalanan. So ang sabi pag positive daw yung y double prime, siya ay minimum. Pag negative, siya ay maximum. So aware ka na kung ano yung maximum. So ngayon, syempre magkaiba dito. So sa SDT, iba yung ating table. So sa table dito, mas maikli tignan yung table dito. Bakit? So for table, so we have point or points. Okay, description. Okay, then since SDT tayo, ito lang ay sine at y double prime. So, wala ka na ibang kukunin. Then, concavity, similar pa rin. Concavity. Then, lastly, the extrema. Okay, so lagay natin yung mga points. Ano yung unang points? Ang unang points natin is yung P1 or yung 2, 8. We have 2, 8. So this is CP. Okay, points na sa y double prime sa 2, 8 is positive. So since ito ay positive, aware tayo na positive siya ay minimum. Tama ba minimum pag pating siya pag positive siya ay minimum. Okay, so kung minimum siya ay upward. Downward yung ano no. So ito ay minimum, then downward. Minimum. So since minimum siya, so yung concavity, pakabaliktad ako. So maximum downward. Minimum, maximum downward yung concavity. So, minimum, upward yung concavity. So, check ko lang din. Okay, so, may isa akong co-correction para sa lahat, para at least matama na natin. So, chinek ko to, dinoble check ko. So, nagkamali ako dito. So, I admit na nagkamali ako doon. So, itatama ko na lang din dito para sa previous video. So, itama nyo na lang din dito sa previous video. So, at minimum, so, for example, minimum yung lumabas. So, sinearch ko na rin kasi iba yung nakasulat sa notes. So, kasi nagdalawang isip din ako totally. Pag minimum, obviously, siya ay concave upward. So, minimum siya pero concave niya is yung direction na is pa-upward. Okay? So, pag maximum, okay, ang concave niya is downward. Okay? So, hoping na natama natin dyan. So, before kong ilagay dito, itatama ko muna dito. Okay, so pag maximum siya ay downward. Again, so pag maximum siya ay downward. So i-check ko lang din dito. So pag maximum siya ay downward, tama. So nagkabaliktad talaga ako totally. So burahin ko to. So pag maximum siya ay downward. Okay, then pag minimum siya ay upward. Okay, so sorry about that. So at least natama agad ni sir para at least hindi na tayo magkamali next time. So this is downward. This is downward. Okay, then this is upward. Okay, so delete sa isip nyo yung nasabi ni sir kanina. Okay, so sorry about dun. O doon sa previous video natin kung hindi ka ganun nanood. So again, since minimum siya, so sabi pag positive minimum siya, so therefore ito ay upward. Okay, so ito ay downward, sorry. So pag minimum, sorry, pag minimum siya ay upward. Nalilito na rin ako sa sinasabi ko, this is upward. Okay, then next is 1,9. So this is also a CP or a critical point. So this is negative. So obviously this is downward. Okay, then this is maximum. Okay, then last is the inflection point, which is 3,2 over 7, 3 over 2, 17 over 2, and this is IP. So aware naman tayo na wala siyang changes. So ayun lang. So hoping na nagets mo to. So again, para sa scoop lang or parang summary lang ng dalawang magkasunod na video ng FDT sa kasi SDT. So huwag tayong malito again dito ha. So dito ko sa second derivative at least na itama. So sinearch ko rin siya. So mabot din talaga ako ng actually 1 hour para i-search siya. So medyo natagalan ako totally kasi nga nagkaroon ako ng konting parang paano ko masabing concave. So sinabi pa lang concavity, sabi ng concave o yung changes niya paangat. So iniisip ko kasi agad is pag upward or pag maximum upward siya nasa taas eh. Hindi pala kasi pababa pala yung concavity niya. Ganun pala nangyayari. So tinignan ko rin mabuti sa ibang books pa. So at least na-verify natin. Again, thank you for watching. So isa lang sa mga ano ko. Ito yung gamitin natin. So hindi mo lalagyan na by FDT. So pwede namang ituloy-tuloy mo dyan. Tapos dito ka naman naglagay. So lagay mo by FDT. Kung mag-fail, SDT. Yan, kung ayaw mo na FDT, nag-SDT ka agad, okay lang. Kung nag-SDT tas nag-fail, kung nag-0 or infinity, automatic FDT ka. So malaya kayong pipili ng test na gagamitin. It's either FDT or SDT. Kasi kusa naman silang nagtuturo kung dapat mo bang gamitin sa SDT or sa FDT or vice versa. Okay, so again, thank you for watching. And again, sorry or medyo nagkaroon ako ng error totally dun sa ating discussion. So napakalit lang naman niya actually, pero napakalaking impact na sa buong discussion natin, sa buong subject natin. So kumbaga baka dumating yung point, may tanong sa inyo tapos sabihin nyo ganyan, then sabihin nyo ako yung prop. So at least itinatama ko. So wala namang perfect about yan. So again, thank you for watching. Hoping na nag-enjoy ka at the same time ay natutunan ka dito sa discussion natin.